In this video, we're going to graph a parabola with its vertex not at the origin. And it says, graph the following parabola by moving the vertex and an endpoint of the lattice rectum. Now, they already have the graph written here correctly. All I'm going to do is I'm going to show how they came up with that. So, first thing we want to look at is kind of our general equations for graphing parabolas and determine which one we have. So we have this y squared equals negative 12 x minus 4. We have y minus 5 squared equals negative 12 x minus 4, which would be this equation here, but just not centered. This one is centered at 0, 0. We can write the equation though. The general form would be y minus k squared is equal to 4p x minus h. So my k value here is 5. My h value is 4. And my 4p value is negative 12. Which tells me when I divide by 4 here, I get p is equal to negative 3. Now, I'm just trying to graph this. So I still think you should start maybe with the foci. So let's find the foci. And to find the foci, because this thing is either opening to the left or to the right, the x value for the foci is changing. So we're going to say that the foci is going to be our h value plus p, comma, the k value. And we also can say that our vertex here is h comma k, which for us would be 4 comma 5. So then we can start plugging in some stuff to find the foci. So the foci will be 4 plus p, which is negative 3, comma k, which is 5. So we end up with the foci being negative 1, comma, oh not negative 1, positive 1, comma 5. So we can graph that. 1, 5 would be 1, 5 right here. So this is our foci. Now I want to find the equation for the lattice rectum. Well, the lattice rectum is always going to equal the y value, or not the y value, the x value of the foci. So we have this x is equal to 5, which is the lattice rectum. And then we need to find the endpoints. So to find the endpoints, we're going to take this x value of 5, plug it in, and solve for y. So we have y minus 5 squared is equal to negative 12, 5 minus 4. If we simplify that, I'll get y minus 5 squared is equal to negative 12 times 1. So I get y minus 5 is equal to negative 12. Y minus 5 squared is equal to negative 12. I'm going to square each side, so I get y minus 5 is equal to 144 when you square the negative 12. But this will be, when I square this, this should be, I should get plus and minus here. Sorry, when I square root this. Wait, that's not working out right. I made a mistake somewhere. So my y value is, sorry, I plugged in the wrong value. I plugged in y, I needed to plug in x. Whoops. So this was screwed up right here. This should have been 1, and I plugged in 5. I'm going to switch this real quick. I'll just rewrite it down here. So we're just going to cross that out. Y minus 5 squared is equal to negative 12, 1 minus 4. So I end up with, this is negative 3 times negative 12. That's 36. So I have y minus 5 squared equals 36. We're going to square root each side. We get y minus 5 is equal to plus and minus 6. add the 5, I get y is equal to 5 plus and minus 6. So my endpoints for the lattice rectum are going to be x value of 1, comma 5 plus 6, which is 11, and then x value of 1, 5 minus 6, which is negative 1. So if I go to graph those, I get 1, negative 1, which is here. And then I could also plot 1 and 11, which would be up here. You can see both of those are on the parabola.